Here's a math problem. I'll give you a second to read it. So first thing I want to point out about this problem that may not be clear is that heading means the same thing as direction. Now, they've given us a lot of instructions here, but they also give us an example. They've got some process that starts with a heading and ends up with a label. So the first thing we should try to do is understand how they got a label of 22 from a heading of 223 degrees. So how should we draw 223 degrees? Well, most of the time when you're drawing an angle, you'll start out with something like this, and you might also sketch in a circle to start representing angles. I'm going to leave out the circle. But before we start labeling these axes, we should make sure that we're following the rules of the problem. So we're talking about non-negative clockwise angles less than 360 degrees, also measured from north. So here's the north. We're measuring clockwise, so angles will increase from 0 to 360 going this direction. So then we can label it 90, 180, 270, and back to north would be 360, but we want less than 360. So let's find 223. That's going to be somewhere around here. Okay. So what's next? We also want to the nearest 10 degrees. Okay. Well, our options are 220 or 230. But I suppose we should pick 220 degrees because that's certainly nearer to the actual direction. Okay, so we've got 220 degrees. And the next step is to divide it by 10. Okay. And we get 22, and that's the label that we were supposed to get. Okay, great. So we understand their example. Now, they're asking, what is the other number on this runway? So this is the visualization problem. Let's try to draw a runway. And it's got a label on one end of 22. And they're asking us, what's going to be the label on this side? Well, how could we possibly know that? Well, we know how to turn an angle into a label. So what's the angle that corresponds to this side of the runway? Well, you can kind of think of it as if we're drawing some axes on this. And here's our angle that we started out with. So to get the opposite angle, you're just going to get to the other, you're just going to look at the other side, and that's going to be a change of 180 degrees, adding or subtracting. So let's draw that. Ooh, I don't like that. So that's going to look like this. And it's derived from this 223 degrees. So we're going to add or subtract 180 degrees to get the angle on the other side. Well, if we added, we're going to end up with 403. But that doesn't adhere to the restrictions they place on the angles. They want less than 360, so we don't want that. So we'll subtract 180 from 223, and we should get 43 degrees. So that's our new angle. That's the angle for the opposite side of the runway. And that makes sense because we're measuring it from the north. And 43 degrees, it's less than 90, but greater than 0. Okay, we did our sanity check. Now, we follow the same process that we did before. So we find this direction, but to the nearest 10 degrees. So our choice is 40 degrees or 50 degrees. Well, we want to go with 40 because that's clearly nearer to 43 than is 50. So we've got 40 degrees. And then again, we divide by 10. So our label should be 4. And what do you know? That is an option. We choose A, and that is the correct answer. The label on the other side of the runway is going to be 4.